Okay, this is just a quick check to see how you got on with the work on Friday. So the first bit, well, you can read that as well as I can. Could you remember how these substances are formed? Remember, aldehydes are formed by oxidation of primary alcohols. The first step of oxidation of a primary alcohol involves an aldehyde being formed, and the next step, if you reflux the mixture, you get a carboxylic acid. That's primary alcohols. Ketones are formed by the oxidation of secondary alcohols. Remember, the oxidizing agent you use is acidified potassium dichromate. So those sort of reactions can be reversed if we use a suitable reducing agent. And the two most common ones you can read as well as I can. There's sodium borohydride or lithium aluminium hydride. Note the special conditions needed: aqueous in water or dissolved in alcohol, dry ether followed by the addition of an aqueous acid. So we're basically using H- as a nucleophile, and that attacks the delta positive carbon in the carbonyl group. Now, from my own experience, when I was at university, I know that this is much safer than that one, because when I was at university, the person next to me used this and basically had, well, a sort of mini explosion. They generated a lot of hydrogen very quickly and it got ignited and went bang. Now, you may recall when we were doing oxidation reactions, you could use square brackets with an O to represent oxygen. Here, for reduction reactions, we can use H in square brackets for the hydride ion. So hopefully you had no problems with these equations. If you did, please just send me a message to let me know. And the little hint here, deduce an equation for the reduction of propanone. The thing here you need to form is, remember, propan 2-ol from that reduction. Second set of reactions. There we go. Can you manage to balance an equation for that bit? That's worth a little try. The actual product, because we've got acidic conditions, is that phenylammonium ion, but this is the key bit that you need to try and write an equation using the H's in. And if we want to get rid of that phenylammonium ion, we add sodium hydroxide, and then we actually go back and produce the final product that we want. Okay, there's that equation for that. That is reduction reactions completed. So hopefully you had no problems with that. If you did, just get in touch with me, please. I'm now going to pop on a second video looking at section 20.2.